Hi students, problem number 12. A deuteron of kinetic energy 50 kilo electron volt is describing a circular orbit of radius 0.5 meter in a plane perpendicular to a magnetic field B. The kinetic energy of a proton that describes a circular orbit of the same radius 0.5 meter in the same plane with the same magnetic field is to be determined. First we have to understand the numerical problem. Two charged particles are given. One is deuteron, 1H2. The other one is proton, 1H1. Both these positively charged particles are entering perpendicular to the same magnetic field. And they describe a circle of the same radius. Okay, same radius. If the kinetic energy of the deuteron is 50 kilo electron volt, what will be the kinetic energy of the proton? We have to find out. So, similar problem with the different situation we have done already. Now, this is a very good and interesting problem. For this, first we must know the relationship between kinetic energy and the momentum of the particles. So, I will take this kinetic energy E kinetic is equal to P square divided by 2m. So this implies P square is equal to 2m into E kinetic. Okay, or P square is equal to 2m into Ek. Therefore, P is equal to square root of 2m into E kinetic. So this is the first expression. But what is this linear momentum? It is a product of mass and linear velocity. So I can rewrite this equation as m into v is equal to square root of 2m into E kinetic. So this is the second step in this derivation. Okay. Now the radius of the circular path, of the charged particle in the magnetic field is given by R is equal to mv by bq. Do you remember, students? Just now in the previous videos we have derived this equation by equating the magnetic Lorentz force and the centripetal force, is it not? So R equal to mv divided by bq. In this expression, numerator mv here, in place of mv, I can also substitute square root of 2m into Ek. So instead of mv, I am going to substitute 2m into E kinetic divided by bq. Okay. So R is now equal to square root of 2m into Ek divided by bq. Okay, after this you square on both sides, squaring on both sides. Okay, squaring this equation. Okay, I will take this as equation 1, this as 2 and this as 3 for our convenience. So squaring equation 3 on the left hand side is R square. So R square is equal to, the numerator when it is squared means the square root will disappear. So 2m into E kinetic divided by b square q square. Okay, so this is a b square q square. Therefore, E kinetic expression is equal to, E kinetic alone I need. So this is equal to R square into b square into q square divided by 2m. So this is the required equation. Now in the textbook, we have already derived this in the cyclotron. Okay, in the cyclotron topic already this direct equation is derived. If you remember this directly, it is well and good. Otherwise also you need not worry at all. Like this we can quickly derive this. Okay. So E kinetic is equal to R square into b square into q square divided by 2m. Now you see, both are having the same radius of the circular path, 0.5 meter. So this R square, no, it will be a constant. Then magnetic field. They are moving in the same magnetic field. Therefore, this d square also will be a constant. And this 2 is also a constant. Okay. Therefore, EK is proportional to Q square by M. Okay. Q square divided by M. So for the first particle, if you want, EK1 is equal to Q1 square by M1, and EK2, okay, EK2 is proportional to Q2 square divided by M2. So what is the first particle? First particle is a deuteron. So that is 1H2. Second particle is a proton. Therefore 1H1. So what is the value of Q? Q in the first particle is Q1 is equal to 1 unit and mass M1 is equal to 2 units. For the second particle, what is Q2 equal to 1 unit and mass M2 is also equal to 1 unit. Therefore, I will take EK2 divided by EK1 is equal to EK2 divided by EK1. So this is equal to Q2 square by M2 into M1 divided by Q1 square. We have to substitute now the right hand side values of Q1, Q2 and M1, M2. Okay. So this is now equal to, what is Q2? For the second particle it is 1 unit. So Q2 square is 1 square divided by M2 is 1 unit. So M2 is 1 unit into M1, the mass of the first particle is having 2 units. So M1 is 2 divided by Q1 square. Q1 is 1 unit. So this also is 1 square. So this is equal to 2 by 1. So EK2 is equal to 2 times, okay, EK1. So this is equal to 2 into EK1 is given as 50 kilo electron volt. So into 50. Therefore, the kinetic energy of the proton is equal to 2 into 50 is 100 kilo electron volt. So this is the required answer. So 250 is not correct. Third option C must be the correct answer. Therefore, option C, that is equal to 100 kilo electron volt. Okay. That option C is the correct answer. So this type of problem is repeatedly being asked in Neet as well as the JEE mains and advanced. Understand? So be thorough with this concept. I have already instructed you that anywhere if you struck up means you can again come from the beginning. So what are the two basic equations required to solve such problems? One is the relationship between the kinetic energy and linear momentum. The second one is the relationship equating the magnetic Lorentz force and the centripetal force. These are the two basic equations. If you remember, means any problem based on this concept can be successfully attempted. Okay, good. I hope you must have understood well. Fine.